And that review is what we're doing today. So hopefully on your papers, you put an X and a Y axis, and you graph the following points. 1, 1, 2, 3, 4. You will notice that I'm not an artist, and I don't require that you be. It's okay if your pictures aren't perfect or pretty or anything like that, as long as I get the general concept. 4, negative 1, and 0, 3. So it should have been those 4 points. Negative 3. Oops. Whatever. Thank you. Any questions on the DOM? Good. An extremely large portion of what we're going to do in here is going to be dealing with graphs. We're going to be doing all kinds of things with graphs of functions, which would be easier if we were using graphing calculators, but in the past I've had so many students that got so dependent on them that if I actually asked them, hey, what are you looking for in this problem? They knew what buttons to hit, but they had no idea what to tell me about what they were looking for. So, because of that, you won't be using graphing calculators until probably the second half of the semester. You're more than welcome to use them on homework and stuff to check your answers or for calculations, but on test day, I'm going to bring in those little blue ones like I told you yesterday. So just make sure that you're not dependent on them when you're doing the assignment. I will do every example up here without the use of a graphing calculator. Like I might use it for calculation, but I won't use it for anything that requires the specifics of that technology. So I won't be cheating. All right. So first part of our review today, plot the given point. Well, we've already done that. You plotted several of these in the DOM, so we're going to skip over these problems, but you are going to have to do that. Only thing that might be a little confusing is fractions. Feel free to convert these to decimals if it would help you. Any questions about what you're going to be asked to do for those problems? Okay. Graph each equation. Let x be those values. So really all it wants you to do is plug these 7 values into each function and then plot those coordinates. We've been doing lots of graphing today. Graphing paper is not required, but it is helpful. I do have some you can use later on, although I'll warn you it's pretty bad. Not great graphing paper. So let's pick one. Which one looks harder than the others possibly? 23. Alright, has an absolute value. I can see that. Alright, so we have to plug in negative 3 to 3. Now, from today until the last day of class, a fail-safe method for graphing is to make an XY chart. No matter how many different methods I'm going to show you to do some of this stuff, and there will be lots, an XY chart is the safest way to do it. You make a list of the numbers you're going to plug into the function, then you plug them in. So, what's the absolute value of negative 3? Plus 1 is 4, 3, 2, 1, 2, 3, 4. That's what you should get when you plug in these values. Raise your hand if there's a specific one of these that you'd like me to explain where I got that. Any one of them, it's okay. I'm kind of sprinting through it. Okay, so now all you have to do is graph them. So once again, you'll need to draw a coordinate plane. Negative 3, 4. Negative 2, 3. Negative 1, 2. 0, 1. You don't have to connect the dots today, but I think you can see the general shape it's going to form. Being that V shape. And that's all you have to do. Plot your points and move on. Questions about anything you see on the board? Is there another problem on the board somebody would like to see worked? Okay. Okay, so let's see. The table of values is generated by a graphing utility. Who cares? Which equation corresponds to y2? So that means if you plugged in these x values into these 4 functions, which function A, B, C, or D is going to generate the list of y2's y values? Who thinks they know that? A, B, C, or D will generate the y2 list. thing to remember is this is really just an XY chart. These are the X's, these are the Y's. Which function generated those X's and the Y's? C, let's see. 2 minus negative 3 is 5, check. 2 minus negative 2 is 4, check. 2 minus negative 1 is 3, check. And I'll assume the rest of them. So very good. Very good. In your calculator, if you were to graph multiple functions, this is the kind of thing. They'd say, well, these are the values for one of them, for the other, etc. Not that we're going to use that, but that's where that's coming from. Does the graph of y2 pass through the origin? Who thinks they know the answer to that question? Does that list we were just looking at pass through the origin? Yes, no, and why or why not? Why?
No, never mind.
You're looking at y1, weren't you?
Y1.
You're right. y1 would be. It does go through the point 0, 0, but y2 does not. So, no. And I think you probably answered another question later on. Question about how we came to that conclusion. The origin, the point 0, 0. If this was my x and y chart, the point 0, 0 is not on it. Now, if it said y1, it would be, but it didn't. At what point does the graph of y2 cross the x-axis? What's the y value going to be when your graph crosses the x-axis? 0, yeah. So at what x value does that happen for y2? Very good. X equals 2. Questions about that one? There's going to be a lot of stuff in here that some people might say, oh, that's easy, or they might just blurt it out, and you might think, oh, then I don't want to ask them, it's stupid. But a lot of times, if you have a question, most likely at least 15 other people do too, but nobody wants to ask it. So please do never hesitate to ask a question if you've got it. At which points do the graphs of y1 and y2 intersect? Where are those things going to cross? And then maybe you could explain to me how you got that. Negative 2, who said that? Negative 2 and what? How'd you get that? Very good. Very good. Their y values are the same. If you were to plot these points and then plot these points, those two would be the same and these two would be the same. Very good. So x equals negative 2 and x equals 1 would be the answer to 39. Questions about that one? Raise your hand if you've had honors algebra and trig. Oh, wow. Okay. All right, then. There's a lot of overlap between the two classes. If you happen to know anybody younger than you who plans on taking pre-calculus, you may tell them there's really no point in taking that class just because a lot of what you learned in there, we're going to do again in here and some different stuff. But I'm trying to discourage the schools from having kids take both just because you're going to be kind of bored a lot this year because there's going to be a lot of things that are covered in both classes. All right, use the graph to determine the x-intercepts, y-intercepts, and I guess that's it. X-intercepts and y-intercepts. Where do they cross the x and y-axis? Where does this one cross the y-axis? Y equals negative 4 and x equals 0. And where does this one cross? 2. X equals 2. What about this one? Where does it cross the y-axis? What about the x-axis? Negative 2 and 1. Now this, I know some of you may be thinking, well, it doesn't cross. That's true, but it does, I guess it should say touch. Does it say touch or cross? Oh, it just says intercepts. So if it touches, that still counts. In fact, it counts twice, but we'll get to that later. You can just list the number today. So negative 2 and 1. What about this one? Where does it cross the y? It does not cross the y. What about the x? Okay. Questions? Believe it or not, that's the entire first section. And I'm not going to fill this class with fluff, so when we're done, we're done. There you go.